All right, in this video, this is going to be part 2 of section 3.10, dealing with derivatives of inverse trigonometric functions. In the last video, we did talk about taking derivatives of the 6 common inverse trigonometric functions and how to do those. And now we're going to look at the derivative of an inverse function. All right, so here's the theorem about that. And it says here, let f be differentiable and have an inverse on an interval called I. If x sub 0 is a point of I at which f prime of x sub 0 is not equal to 0, then f inverse is differentiable at y sub 0 is equal to f of x sub 0, and f inverse of 1 prime of y sub 0, or the derivative of the inverse function at y sub 0, is equal to 1 over f prime of f sub 0, where y sub 0 is going to be equal to f of x sub 0. So here we're going to let x sub 0, y sub 0 be a point on the graph of the function f. This will mean that y sub 0, x sub 0 is the corresponding point on the graph of f inverse. So here, when you're finding the inverse for an ordered pair, if you're given an ordered pair, its inverse is just switching the x and the y coordinate around in different positions. So x sub 0, y sub 0 means that the inverse will have the point y sub 0, x sub 0. The slope of the tangent line for f inverse at y sub 0, x sub 0 is the reciprocal of the slope of the tangent line for f at x sub 0, y sub 0. All right, so let's look at some examples of this. Let's start by finding the derivative of the inverse of each of the following functions at the specified point on the graph of the inverse function. Now here you do not need to find f inverse. Okay, so you're not going to do like we did back in college algebra where you have to find out what f inverse is. So we're not going to do that here. In example 10, you got f of x is equal to 5x minus 7, and the point is negative 17, negative 2. Okay, that's going to be the point for f of x. Well, now for the point for f inverse of x, let's start there. Excuse me. The point for or of f inverse of x would be this. All we do there is just switch the ordered pairs around. That means this will become our x coordinate and the negative 17 becomes a y coordinate. So negative 2, negative 17 will be the point for the inverse function, f inverse of x. Okay. So that means here, using this right here, we have f inverse of x, or f inverse, or the derivative of f inverse of y sub 0 is equal to 1 divided by f prime of f sub 0. Okay. So now in this case, you can see that your negative 2 is going to be x sub 0. Y sub 0 will be negative 17. Okay, so now let's do some substitution here. F inverse prime of y sub 0, that's negative 17. That's equal to 1 divided by f prime of x sub 0, which is negative 2. All right, so first of all, we need to find out what the derivative is for f of x. Well, since f of x is 5x minus 7, let's find out what f prime of x is going to be. So we just take the derivative of 5x minus 7, which is simply going to be 5. Okay. Now we can find out what f prime of negative 2 is. Well, there's no x value. There's no x to substitute in. So f prime of negative 2 would just simply be 5. Okay. So now, all we do there is just substitute f prime of -2, which is going to be 5. So that means the derivative of the inverse function at y sub 0 being 17 will be 1/5. Okay, and that's pretty much all we had to do with that problem there. All right. Here's another example. Excuse me. All right, let's say we had f of x is equal to 5x cubed minus 9x squared minus 6. And here our x is greater than or equal to 1.5, and the ordered pair for that function is 750 and 6. 750 and 6. So for the inverse, the ordered pair, or the point for f inverse of x, would be this. We just swap the ordered pairs, around. That 6 will be your x coordinate, 750 will be the y coordinate. So that would be the point for f, for the graph of f inverse of x, or for the equation of f inverse of x. Now, using the fact that we have f inverse of, well, f inverse prime of y sub 0, that's going to be equal to 1 over f prime of x sub 0. So here we're going to substitute the y sub 0 with the 750. So it would be f inverse prime of 750. That would be equal to 1 over f prime of x sub 0, which is 6. But let's find out what f prime of 6 will be. Not 6. I just need to find the first derivative first, and then we can find out what it will be at x is equal to 6. So here's my function here, f of x equal to 5x cubed minus 9x squared minus 6. So if I take the derivative of that, it will be, and it might help if I go ahead and write that. So bring the 3 down, multiply by 5, it'll be 15. Copy the x over to the 1 less power, so it'll be 15x squared, minus, bring the 2 down, multiply by 9, you'll get 18. Copy the x over to the 1 less power, so it'll be x to the 18, x to the 1, or just x. The derivative of minus 6 will be 0. So f prime of x will be 15x squared minus 18x. And now we can find out what the value of f prime of 6 will be. So here we just substitute each x with 6. And we can use our graphing utility to calculate 15 times 6 squared minus 18 times 6. All right, clear this out. I do 15 times 6 and then square it, minus 18 times 6. And that would give you 432. So f prime of 6 would be 432. So I'll just substitute that f prime of 6 with that 432. So f inverse prime of 750 would be 1 over 432. And that's all they asked for here. So the derivative of that inverse function at 750 will be 1 over 432. Okay, let's look at a couple of more of these. like this one. Here we're given the function f, find the slope of the tangent line to the graph of f inverse at the specified point on the graph of f inverse. Okay, so now we got f of x equal to the square root of 2x, and the ordered pair this time would be 2, 2. So in this case here, the point for f inverse of x would be, well, pretty much if we switch the ordered pairs in their positions, switch the positions of those coordinates, it'll still be 2, 2. Okay, and then we use, of course, f inverse prime of y sub 0. And that will be equal to 1 over f prime of x sub 0. So this is x sub 0, this is y sub 0. So y sub 0 will be 2, so it'll be f inverse prime of 2 is going to be equal to 1 over f prime of 2. But now we need to find the derivative of f of x. So here f of x is going to be equal to the square root of 2x. Now the derivative of the square root of anything, and I hope you remember this, if you have f of x is equal to the square root of x, then its derivative is automatically going to be 1 over 2 square root of x. So that's what we're going to use here. So here the derivative of the square root of 2x would be 1 over 2 times 1 over 2 times the square root of 2x. But we also have to multiply that by the inside derivative. What's inside the radical? That 2x, we need to take its derivative, which is going to end up being 2. And then after that, as you can see, that the 2's will divide out, and you will be left with simply 1 over 2, 1 over square root of 2x. As the 2's divide out. So it'd be 1 over the square root of 2x. Now let's evaluate f prime of 2. And that's by replacing the x with 2. So it'll be 1 over 2, the square root of, let me correct this, over the square root of 2 times 2. So this will be 1 over the square root of 4, and the square root of 4 is 2. So f prime of 2 would be 1/2. All right, so I'm going to substitute f prime of 2 with the 1/2 because that's what it's equal to. So f inverse prime of 2 equals 1 over 1/2. But this is like the reciprocal of 1/2. So if I take the reciprocal of 1/2, that's going to end up being 2. Okay, and you can pretty much verify that using your calculator by doing 1 divided by, and in parentheses, 1 divided by 2, close parentheses. You'll see you'll get 2 as your final answer. So the slope of the tangent line to the graph of f inverse of x at the point 2, 2 would be 2, okay? So anytime you know when you take the derivative, you're taking the slope of the tangent line And this is of f inverse of x in this case. Okay, here's the last example. Let's say I want to find f inverse prime of 6 if f of x is equal to x cubed plus x minus 4. Okay, so now what this means is this. What that means is this. Here we're going to let y equal to this 6 right here, because it follows the fact that f inverse prime of y sub 0, so that means your y has to be 6. Since y is equal to 6, we need to find out what x is such that the function f of x would be equal to 6. Okay, and here f of x is x cubed plus x minus 4 that's your f of x. And we want to know what that is so that, what x is, so that x cubed plus x minus 4 would give us 6. And unfortunately, we're not going to be able to factor the left-hand side to find out what that x value is going to be. So the best advice I can give you there is use a graphing calculator to do this. All right, so I'm going to go to y equal to, let me clear this out. And then y equal to, I'm going to type in that function x cubed plus x minus 4. So I'll get my x using xt theta n for the x. Use the hat key for the exponent, type in the number 3. To cube it, use the right arrow key to get out of the exponential part, then plus xt theta n for the x minus 4. Now I'm going to go to my table. So here I'm going to go to second and table. Now, if you haven't done this, you might want to do this. Go to second and table set. You might want your table set to start wherever a whole number is. Table, the increment will be 1. But if you have ask highlighted, what you want to do here is use a down arrow key and then press and put the cursor above the word auto and press enter. Okay, it'd be best to do it that way. Now go to second graph for the table. Now, in this case, you want to find the x value that would give you -6 as a y value. I mean, gives you 6 as a y value. And if we scroll down a bit, here's the y value of 6. The corresponding x value for that would be 2. Okay, so that means if y is equal to 6, then that means from the calculator, x is equal to 2. And this is from the TI 84 plus calculator. Since y is equal to 6, that means that x has to be equal to 2. So now we can find f inverse prime of 6, which is going to be 1 over f prime of that x value, which is 2. Now let's find the derivative of that function f of x, which is equal to x cubed plus x minus 4. So f prime of x would be, bring the 3 down, copy the x over to the 1 less power, that's 3x squared, plus the derivative of x is 1. The derivative of any constant is 0. So that means f prime of x will be equal to 3x squared plus 1. And our x value is going to be 2. So we just substitute the 2 in for each x. So the f prime of 2 is equal to 3 times x, which is 2, that will be squared, plus 1. So for f prime of 2, that will be, now 2 squared will be 4. 4 times the 3 would give me 12. And then 12 plus 1 ends up being 13. So f prime of 2 will be 13. That would mean that f inverse prime of 6 will be 1 over 13. So this is what f inverse prime of 6 would be equal to. 1 over 13. And that also represents the slope of the line tangent to the graph of f inverse of x at the point when y is equal to 6 and x is equal to 2. Okay, so that does conclude this video on section 3.10, which is actually part 2 of section 3.10, dealing with derivatives of inverse trigonometric functions. Feel free to contact me by email if you have any questions or concerns about problems that were presented in this video or any other problems in the homework for section 3.10 on my MATLAB.